We are NuSpatial. We're transforming real places into digital spaces. You can find us on the web at NuSpatial.com. We're on Twitter at NuSpatial. We're Facebook.com/NuSpatial. And I'm Michael Carroll. You can find me on, I guess I don't have a personal website at the moment, but you can find me on Twitter at CarRomJ.
My code is broken. My code is broken.
From Huntsville, Alabama, you are listening to My Code is Broken, a podcast by developers for everybody. Here is your host, Dan Nagel.
My code is broken. My code is broken.
Hello friends, this will be the last episode of My Code is Broken. I'm going back to school in the fall, and looking at my schedule, I don't think I can deliver a quality show. Therefore, I'm canceling the podcast. I'd like to thank everybody that encouraged and supported me as I tried this venture. I'd like to thank everybody that volunteered to be interviewed, too. The show has gone some format and process changes as I learned better ways to do things. I hope a few years from now to be able to take these lessons learned and start another, and ideally better produced show. But until then, here's the final episode. I interviewed Michael Carroll from NuSpatial, a new company that produces as-built plans from buildings just by walking around with a tablet and a backpack full of sensors. The show was recorded live. Here it is. Alright, this is My Code is Broken, episode, I forgot what episode I'm on. 7.
But I think
7. Episode 7 with, go ahead and state your name.
my name is Michael Carroll. I'm with NuSpatial.
Alright, tell me about NuSpatial.
NuSpatial is a newly formed entity. It's actually formed from the merger of two already existing companies. One was Robotic Paradigm Systems, based here in Huntsville, and the other was GB3 Scout, based in Atlanta. And previously, RPS, Robotic Paradigm Systems, created a backpack-based mapping system. So it was a set of technology that had a sensor head mounted on a backpack where you could walk through a very large piece of real estate or industrial space and generate as-built floor plans, documents.
Now, which side did you work for before the merger?
I worked for the Robotic Paradigm Systems side, so I was with them for about a year before the merger.
Right. Now, what's interesting about this merger is, I looked it up, and your domain name is barely 2 months old, so this just happened, didn't it?
Yeah, the paint is still wet on there. The ink is still wet on the documents of the merger. So we have been in talks for a little bit, but it just finalized just a few months ago.
So these two companies merged, and now both entities are now just NuSpatial?
That's correct. So the new entity is NuSpatial. So it's NuSpatial.com, NuSpatial on Twitter, Facebook, Google+, anywhere that you look, that's what we're identified as. But basically, we've switched from a product focus, whereas before we were actually building the backpacks and the software with the intent of selling it. Now, after the merger, it's a services focus. So the group in Atlanta is a group of construction, architecture, and engineering professionals that basically utilize our technology to accelerate their process. And so they're the people who actually will go visit on site and generate the documents that our customers desire.
And what is your role in all this?
My role, I'm a robotics software engineer, so primarily my focus is on taking our hardware and our sensor systems and figuring out new and exciting ways to put them together. So that largely is evaluating new sensors, so we're constantly buying new gadgets and toys. We have probably every 360 camera that's hit the market in the past year, and then figuring out how to integrate those into either our current product or new prototype projects that we have coming. So the kind of core problem of all of this is figuring out where this sensor system is inside of a building while also generating a map of that building.
When I think of robotics, I think of, things moving around, servos, but this system seems pretty discrete. So your expertise is in the sensors, is that?
Correct. So robotics is a very large field, right? So there's several different facets, and one of those facets is perception and state estimation. And so state estimation is primarily historically it's probably been more kind of an electrical engineering or aerospace engineering type role, but it's very critical in robotics, right? Like if you have to have a car that can drive itself, that car needs to know where it is. It's a core part of the robotics problem. So it is kind of misleading. It's hard to tell people that you're a robotics engineer because everybody expects that you have robot arms.
Yeah, they think of BattleBots.
Yeah, BattleBots, or the Honda or Toyota plant, where they have big robot arms.
So some kind of movement.
Yeah, and so I don't think that's necessarily the case, right? There's a lot of people thinking very hard about very complex problems that we would consider robotics, but don't necessarily have moving parts, right?
Right. I believe one way to think of it as the Google automated car, is a robot, but probably the most boring part of the car is spinning the wheel. So there's
right.
all these incredibly complex software and sensors going on, and the actual turning of the wheel is after all those decisions are made.
Right. Yeah. So it's often easier. I believe there was a series of videos from National Instruments Engineering Mind a few years ago, and one of them was the guy saying to the extent of anytime somebody asks what you do, you just say, I do robots, right? I mean, if you're an electrical engineer or you're a software engineer, a lot of times, you could be working on a complex radar system or a missile system or a piece of software. It's just easier to explain to your family that you do robots.
Well,
right? But in my case, I actually do robots.
I write a lot of network code. Can I say I do robots?
Sure.
All right.
Yeah, I mean, intelligent agents that are. Yeah, I don't know. I'm sure you could make an argument. It depends on who you're explaining it to, right?
Okay.
At some level, an automated script is a robot, right?
That's true. That's true.
So it's oftentimes easier to just say I do robots, and then you can both drink your beers and then go on to talk about something else, right?
I'm going to get back to the two entities.
Sure.
So one side was robotics, and what was the other side?
So the other side was GB3 Scout, and so these are people who
GB3 Scout.
GB3 Scout, yes. So they had a lot of experience in the construction industry, and when they first saw this backpack system, they were very excited about the potential, and so they started GB3 Scout as a company that would leverage RPS's products into a service, right? So kind of with the idea that they could eventually, I think, franchise out or have multiple like GB3 Scout offices providing the same service based around the hardware platform that we were providing.
I'm wondering how the marriage of the two companies came about. Like, did your CEO bump into a bar, the other guy's CEO, and was like, hey, my stuff fits well with yours, my stuff fits well.
Well, so part of it is these companies were founded pretty much at the same time, right? Because GB3 Scout existed because they were going to leverage this technology, right? So it was a as-built construction document company, and they were going to do it faster, better, cheaper than everybody else because they had priority access to our hardware. So there was already an existing.
So they're a prime customer.
There was an existing business relationship there, right?
Okay, so a customer became a merger.
Yeah.
And
at a certain point,
that makes perfect sense.
Yeah, at a certain point, it just made more sense for everybody to be together, and it's been pretty short. It's obviously only been in existence for a little while, but it's been really good, right? So we get a lot of feedback. That it's not necessarily two people doing business together. It's two people on the same team, right? And so now the people who are out in the field and the people who are generating documents from data collected in the field and the people creating the hardware and the software that those people use are all on the same team, right?
Right.
Figuratively and literally. Right? And so while communications were good before, they're great now. And so it kind of allows more of a, I don't know.
You're aligned.
Yeah, I'd say that probably makes a lot of sense. So it's been a really exciting time.
Did the customer bases from each side map over?
Yeah.
Okay.
Yeah. So
All right. Now, is this your only product? Your mapping? Is it called mapping? Is that a good name for it?
The RPS's product was the RP scan. So it's a backpack based mapping system, and NuSpatial is a service company. So primarily, we contract out to various groups who want construction documents, as-built documents generated. So if you have a hotel, or you have a school, or you have a business somewhere that has maybe had multiple renovations before, or was built at some point in the past and has had modifications to the building, and that building needs to get renovated, the first thing that an architecture or construction company is going to want is an updated set of blueprints. And so we get contracted under that architecture or construction company and go and generate those floor plans.
Right, and you do this by taking a device with a backpack full of sensors, walking around, and dynamically a 2D blueprint, I guess, emerges. Floor plan. And I guess the additional measurements are stored till you get back to the office.
Sure. Yeah.
Right.
So there's some amount that happens on site, and there's some amount that happens in post processing, and so. Yeah, so the final product is typically a AutoCAD, a DWG file from AutoCAD or
Google Sketch.
So we don't have very many people request Google SketchUp. The kind of de facto standard in architecture and BIM, building information modeling, which is kind of what we do, is Autodesk Revit, and so Revit is kind of like AutoCAD, but rather than drawing like lines and arcs and things like that, you're drawing walls and foundations and curtain walls and windows. And so it's sort of like AutoCAD, but your kind of most atomic feature is an architectural feature and not a line element.
Building blocks.
Is this like the Maya of architecture, what you deliver to them?
Based on my understanding, yeah, it's pretty ubiquitous in architecture and construction, and it's becoming even more. This whole concept of building information modeling is becoming a bigger concern.
Were you already familiar with this tool before you start?
I was not. No.
You had to teach yourself some of this tools.
So fortunately, I don't have to interact with Revit too much. We have people who are very, very proficient at Revit who work with us, and so the extent of my Revit knowledge is being able to generally open drawings and move around in them. But
is this kind of like Excel wizards working in finance?
Yeah, it definitely takes this special knack. Like, I think a lot of it is having a background in construction and architecture, and so the people that go on site and the people that do the post-processing all have a background, a history in this field, right? And so there are things that they see and the things that they know to look for that I would never have had any idea to look for, right? And then as far as actually moving around in the software and working with the data, it takes this kind of spatial awareness that I guess I just don't have as well developed as they do.
Your role would be, are you the one walking around with the backpack and the tablet?
I do not. No. So
can you tell us about that? Because that sounds really interesting.
Yeah. So
it's an Android tablet.
Correct. So it's a backpack based system. It's pretty light. You can wear it for several hours.
What kind of Android tablet is it? Is it a custom one?
No, it's not. It's not a custom tablet. It's just an off-the-shelf tablet.
Could it like a Samsung
Yeah,
tablet?
like a Galaxy Tab, whatever, 8-inch, whatever Samsung's got out right now.
And it's a piece of software that y'all wrote that you put on it.
Yes.
And is the sole purpose is to connect to all the sensors in the backpack?
Correct. Yeah. So most of the processing actually happens on the backpack system itself, and the tablet.
Well,
is
the tablet's just a viewport.
It's
Basically.
a user interface. Yeah, it's a
Okay.
very convenient user interface. So
It's like a cheap screen at that point.
Well, it's got touch too.
Well, I know, but is it? Well, to me, it's just it's a UI.
Right.
It's a UI to all the stuff going on in the backpack.
Correct. Yeah.
Okay. I was thinking some magic was going on, but it's a UI.
No. So the sensors, everything's primarily on the.
How does
on
it
the
talk
backpack.
to the tablet? Is it Bluetooth, Wi-Fi?
Wi-Fi.
Okay, so you have a
We
you have a
have-
Wi-Fi access point in your backpack,
Mhm.
and the tablet connects to that.
Yeah, and we have various ways. I know there's places that are, especially in Huntsville, that are places that get concerned or itchy around Wi-Fi. And then, for a while there were places that were actively suppressing Wi-Fi. So we have workarounds in our.
There's
our
lots of ways. You could do a Bluetooth connection. You
Yeah,
could-
so
you could do
the
NFC. If you
yeah,
get
the big thing
desperate.
is no emission, right? So typically near closed areas, you're not allowed to have devices that emit radiation.
Wi-Fi radiation is.
Yeah. So
Oh.
like if you're
Communication.
it's a very common thing. It's a very common thing in Huntsville, but if you're working on the commercial side, you probably don't encounter it very much. But when I at a previous employer, when we were testing robots, we were testing indoor ground robot navigation, and we wanted to test in the hallways of the office that we were in, and because it had closed areas, you're not allowed to have Wi-Fi, cell phone, Bluetooth within, I don't know, whatever the security office says, 6 feet of the door, right? And so basically that means that your robot has to drive on the opposite side of the hallway from any of these doorways.
Well, could you just have the sensors running and then you look at the tablet later?
Right. Yeah. Exactly.
Okay.
So we have workarounds for not having in places
Okay.
where cameras aren't allowed. We don't need cameras.
So you don't get the
if
nice
they're-
screen. You just had to.
Yeah,
Yeah, the way
and
around.
and there's an understanding that it takes longer and it might be more expensive to do it that way. But if there's a certain subset of customer that requires that you don't use cameras and you don't use Wi-Fi, then they still need floor plans like everybody else. Right?
So what are all the sensors that are in the backpack? Can you tell us?
In broad terms, yeah. So it's a variety of sensors. It's we use computer vision cameras and inertial sensors and LiDAR. All fused together.
Right, and do you have is there GPS going on? And
It's possible to, but I don't know if you're aware, but GPS doesn't work particularly
I know, I was
well
wondering that,
indoors. So there's a lot of solutions for getting very accurate position and measurements outside, but a lot of those solutions don't necessarily exist for the inside.
So all the sensors and the tech behind it's highly proprietary, and you're not going to be able to tell me
Yeah,
much about
so
it.
so some of that stuff is definitely secret sauce. So if I told you how to get accurate floor plans on the inside, then you could just do it yourself. You wouldn't need me anymore.
But what in general, the three major types of sensors?
Yeah.
What do they? They obviously complement each other.
Right. So the technique is sensor fusion, right? So you choose different sensors that can complement each other, and you put them together in a way that gets you the best. So the kind of in the broad academic sense, that's the SLAM problem. So it's simultaneous localization and mapping, and there's plenty of literature on this, right? So it's a big academic problem, and then it's also an interesting kind of implementation problem as well. But generally, you have a set of measurements, and you have an unknown trajectory, and you have an unknown map, and you want to solve for the trajectory and the map that are most likely given the set of measurements that you've seen.
You said most likely. Does that mean you're using some kind of statistics?
Everything's statistics, yeah. So Bayes' theorem figures fairly heavily into what we do. I mean, I guess it's foundational to what we do. But yeah, statistics are, because every sensor is noisy, right? Every sensor lies, and every sensor lies in its own unique, fun ways. And so a big part of that is characterizing how the sensors are incorrect, characterizing the sensor models, understanding how each one has its own unique failure modes, and compensating for each other and putting all of that together.
So are you doing a lot of code in R? R, is that the big stats language?
So I do not do very much R on a day-to-day basis. I typically live in C++ and Python. So Python, I like Python, and I've given a presentation here at Co-working Night on using Python as an alternative to MATLAB, right? So Python has a lot of linear algebra extensions and scientific extensions. So if you need, if you need to do a singular value decomposition, NumPy will provide that for you. Or if you need a Butterworth FIR filter, you can get one of those from SciPy. As well as there's just a whole bunch of kind of frameworks that are super convenient for plotting data and manipulating data and schlepping data from one format to another and that sort of stuff. The problem is that in general, Python isn't sufficient for the speeds that we need.
So all these stats calculations that you're doing, is that going on inside the backpack? And then like what are you doing inside the backpack that makes you give a preview display that you need to wait till you get back to the office to give a further, the final product? Like, why can't it all be done? Why can't you walk around the building and then, boom, you have the final output? Like what's going on at the office?
So it's pretty close to that. The biggest thing is getting the data into the Revit format, right? So that's still human intensive, and then you kind of have to think of the thing that's currently generated off of the backpack is largely just sort of a schematic view of the building, right? So it's this 2D floor plan, and a lot of people want additional data sort of hung on top of that schematic. So the operators have the ability to add audio annotations, add video annotations, add text annotations. And so like as they're going through, because they have a history in construction and engineering, they're making notes of the things that are going to be part of that deliverable. So you could think of if somebody wanted to do an audit of their security system, then you'd walk through and you'd make notes of where all the security cameras are and where the alarm bells are and that sort of stuff. And those things, obviously have to get imported into Revit and added, right? So there's always sort of a human element there that's lending their special expertise. We're just sort of accelerating the process, right? Where the technology is accelerating the process, whereas a lot of people go out and do this on graph paper or whatever, right? Or they just hand sketch it on the back of a napkin, or obviously an architectural firm's not going to do that. But
how accurate is it? Like, say you walked around the building, and then I came back later with my tape measures and I did it myself. It's like, what is the accuracy variance?
So it largely depends on the application. So that is not an easy thing to state, right? So in general, substantially less than an inch is what we go for.
Okay.
So it's hard. So that's definitely something that is a conversation with customers. So we can get it very, very accurate, but it usually requires some additional field time.
Is it getting more data for the statistics? You go over the room 3 or 4 times and it gets more and more accurate each time you go over?
So there's additional things that have to be done to drive the accuracy down more. So one of our advantages is that we're very, very fast. So there are systems that exist that will give you 1 to 2 millimeters of accuracy, but they're usually fairly complex, heavy, big tripod systems. They take a lot of site preparation, and that you have to clear out rooms. Nobody can be there. They take time to scan this, you don't have to have the people leave. Nobody has to leave. Nobody has to. It doesn't take any particularly special site preparation. You just walk through at a normal walking pace.
Well, if the business does not have to shut down for the day, that probably pays the difference right
Yeah.
there.
So I mean, I recently tagged along on a scan, and we had to do a hotel kitchen, and that hotel kitchen doesn't stop because it's a hotel, and they have conferences, and they have room service, and they have breakfast, lunch, and dinner. And if you told them that they weren't allowed to be in the kitchen for a few hours, it wouldn't be an option, right?
Right. When you say fast, I'm not familiar with this field. Like, how long does it take you versus, going whatever the traditional way would be? Like, say a 3-bedroom house. I wanted to map a 3-bedroom house.
So we say that would take longer to drive there and drive back. So we can do anywhere between 10 and 40,000 square feet an hour, depending on the place.
Oh, okay. All right. Well, okay, not a 3-bedroom house, a small office building.
So I think we did we were doing some testing here on the 9th floor, and I think we did the 9th floor of this building in less than an hour or so.
Okay, so what is the traditional method is tripods and such?
So, there's two ends of the spectrum. You could have somebody actually drawing it and measuring by hand.
Okay, I want the
tripods.
I want a similar accuracy that you would provide using the traditional method.
Classical surveying?
Yeah, it would be basically classical surveying. So
how long does that take?
I can't even imagine, especially like upstairs. I think a place that we do really well is when there's lots of individual rooms, right? Because if you had a tripod system, you'd have to do a static scan in each of those rooms. So you'd have to move the tripod into each room. And you would have to have scans that had substantial overlap between the rooms.
And then you had to piece all those parts together.
Correct.
And that's an extremely time-consuming task.
Yeah. And a lot of times, they didn't really want a full 3D thing anyway, right? So it's delivering the data that has the highest value and the highest impact to the customer with the right price point and the right timeline.
So, okay, typical customers. So you're not in the residential for the most part.
Yeah, residential doesn't make a lot of sense.
No.
Because our on-site time is pretty short. It really makes sense to have somewhere that you can go, right, and you can be there.
Did you walk around your own house and map it out for kicks?
I have, yeah. I've done my house, and I've done my parents'
Do you want to
house.
do my house? My wife would love it.
So using it for floor plans to do something else with.
Yeah, so the areas that we've kind of generally been interested in are commercial real estate. So anybody dealing in volumes of commercial real estate that need to get square footage verification, right? Because a lot of commercial real estate transactions are based off of square feet, right? And so leases and purchases and that sort of stuff. A lot of times, so we've done schools, we've done churches, we've done hotels, we've done a lot of kind of what you would consider like strip mall type places. So obviously the larger the square foot, the better, right? It's better for us.
Sure.
And you're growing.
But we perform. The system works very well, right? It just doesn't make sense in like something the scale of a house.
Right.
And you're growing in size.
Yeah, so
is the bottleneck you just need more boots on the ground to walk around and collect the data? And I guess you need also analysts to look at the data and piece it together.
Yeah, so I can't speak to, what, I don't know what our current like utilization is on that side of the house, right? So obviously more, better, and faster are always the goals.
Are you worried that somebody will come out with a phone app that's crammed full of sensors to where that would do the good enough job for me where I wouldn't need your help?
So I've evaluated the Tango, right, which I think would be kind of what you have in mind, right? Google has a phone,
Yeah, there's lots
a
of
tablet that has a special sensor suite in it.
right.
It's not there yet, right? So,
But
and
it
Lenovo
could-
just announced theirs, and based
Well,
off of
it could be it's the good enough problem. It could do a good enough job, to where
So
I mean, there's lots of stuff out there that just does not that great a job, but it's good enough, and then it kills the professional market.
So I don't think it would be good enough for the
That gets back to
applications
your
that we're
customers
talking
out.
about.
Because your customers are businesses and they need something serious. Is that
The other problem with those sorts of things, a lot of times you see people use them and they use them in pretty constrained environments. So they have the phones and that kind of class of sensors have a pretty limited field of view, and so you generally have to move very slowly and very methodically, right? And so there are companies out there that do kind of space digitization or whatever, but they're substantially slower, and then they're built around those sorts of technologies, right? So I think they're 1,000 square feet an hour or something like that.
Well, do you think it might possibly catch up to you?
Well, we're improving too. So
Okay.
so I mean, obviously, cell phone sensors or sensors in general are getting cheaper, right? They're all getting cheaper, which has really enabled a lot of this type of stuff, right? Like these type of sensors have gotten, I don't know. I bought a stereo camera for my undergraduate project, my autonomous lawnmower, and it was several $1,000s, right? And I bought one 2 months ago that was several $100s, and it came with a CUDA SDK. I mean, like, and the other thing is, like, you talk about processing power. Processing power is getting cheaper all the time. So I bought one of the first CUDA cards for, I don't know, $700 or something, right? And now you can get the Jetson. You can get a tablet that has like 256 or 512 compute cores for $400, right?
Your undergrad budget was way higher than mine.
We had a very
nice.
nice lawnmower.
I see that.
So we, it was a lawnmower with GPS, IMU, stereo camera, LiDAR, and it would go out and compete in a grass mowing competition that John Deere and the Air Force Research Lab put on. It was good times.
Did you guys win?
So we got third and second. We never got first. So, as a testament to the mechanical engineers on the team, though, the last year that we competed, another team actually built our lawnmower from our construction documents that we submitted as part of our report. So, like, our CAD was thorough enough that you could rebuild the lawnmower from it.
Wow.
I built for my senior design a theremin,
Oh, yeah?
and it didn't work.
Oh, no. So the trick with the theremin is those getting those LC tank circuits tuned, right?
No. The trick to the theremin is to actually work on it.
Ah, that helps too.
We didn't work on it.
Yikes.
Well, what happened was I found out ahead of time that the TA and the professor didn't actually look at your project. He only read the document. So that's all I did was work on the document. I didn't actually work on the project.
Wow, well, that's optimization.
So-
That's 80-20 principle at work right
That's playing the
there.
game.
So I got 100 and all the bonus points on all the documents, and then we bombed the project and it averaged out to an A.
Nice.
Yep. It's called.
Sounds like there might be a flaw in that system.
Yeah.
And he put it together. He put it together.
So
That's reading the specs. And
So I have to
requirements.
say, one of my favorite professors in school, he did. Well, I wouldn't call him my favorite. He had something that I really enjoyed. So he did multiple choice tests. He was a thermodynamics professor with a multiple choice test, and he. Well, we can talk about it later when it's not being recorded. But his whole thing was that with partial credit, there were people who could get through undergraduate without ever working. That's all right. Thank you.
Sorry, I interrupted.
So there are people that could get through undergraduate coursework without ever working a problem all the way to the end. And so he made his thermodynamics tests multiple choice because, by God, you had to work the problem to the end and get the answer. Right? So there's no, I mean, when you get out in industry, there's no waffling, or maybe you can waffle, but I don't know how long you could do that before you'd be let go. But yeah, you gotta, his whole argument was out in industry, you gotta work the problem to the end. You can't, there's no partial credit. So I thought that was kind of cool.
Well, I'm going to open the floor to questions.
How much does it weigh?
So that one's probably light. That's a prototype. So that one
Can we
actually
pick it up?
has yeah, you can pick it up. It doesn't have the battery on it, so it's a little bit light. So that's a prototype of kind of one of the directions we're looking at going.
Oh, of advanced.
Yeah.
setup.
So yeah.
Just walk around with this.
And so it's pretty stripped down. I've taken some of the toys off of it. So yeah, and I can show you guys, and I can post online some of the. I think we showed it off at the Tech Vet, the sort of data that this produces. So this one actually has an articulated sensor head on it, and it will generate data in 3D as well. And so the goal is to sort of speed up automated, extraction of features, and more data is always good, right?
Now that backpack is basically the family jewels,
Yeah.
basically. I mean,
Well, the services, right? So the
but
actual.
you won't sell the backpack. You explicitly say on the website that you will not sell that backpack.
Well, I mean, Dan, if you wanted to make an offer,
I mean, 'cause then
I'm sure we could be convinced.
Well, it's all
Well,
about
let me
the
just
backpack.
ask my the podcast sponsor.
Yeah. So the no, we don't sell hardware, and it's so part of this relationship now, this sort of merger that I'm excited about is that rather than having a single product, the backpack that we sell and give to people or lease to people with services and support and all that stuff, now we can have a spectrum of technology solutions, right? So the backpack, in my mind, is just one thing in a family of multiple things that, depending on the unique environment that the customer has and what exactly they want, we can bring in different components and different modules such that we can kind of outfit our teams to be most prepared for the jobs that they're going into.
Right. It makes perfect sense to me. I mean, your product is not the backpack. Your product is, we're going to accurately and swiftly map your building.
Right.
That's what the customer's buying.
And
The
it's-
customer doesn't particularly care how you do it either.
Precisely. Yeah, and the product is, I mean, it's expensive, right? And it's not just expensive in terms of hardware and intellectual property, it's expensive in terms of training, right? So somebody who does this all day, day in, day out, is substantially better at it than somebody who does it even once a month, right? Like when I do it, it's a joke. It's awful. Right. I mean, not terrible, but
it's better
but
job.
I'm so slow and
Better
so,
job than I would do it.
Probably, yeah. But I mean, it's not without some
Finesse.
Not even that. I mean, that one's pretty easy. You could slap it on and generate blueprints, right? It's a pretty easy system to use. But as far as the whole process altogether, to get the kind of data that the customers are interested in, it does take some insight and some finesse and subtlety, right? You're not just gonna.
I'm so far, all the things you said, what makes me most excited about your service is when you said that business does not have to shut down for you to do it. You can just walk around in the background and not disturb anybody.
Yeah, so if you thought of,
I mean, that is amazing.
Hotels or restaurants or, a college campus where you could go in and get in and out of buildings on a college campus without being substantially disruptive to the activities that are going on. Yeah, it's a huge productivity win. Like, you don't have to evacuate an entire building to do this. Right?
Do you have to go back later and filter out all the people and students walking around? Does that confuse your software?
So we can, we filter it out. So we have.
Do you just come back later when the person's not there, and that's how you?
Well, I mean, we're getting a lot of observations, right? So it's scanning constantly, and so generally, if you have somebody moving versus something that's not moving, like a
tree.
wall
So,
or a tree.
so it shows up in the stats log of movement,
Yeah,
and they can filter.
you can see it and you can filter it out.
What if someone's really still?
Yeah, that's what I was thinking. Like,
Yeah.
people just stand there, they see you come in and just stand against the wall and just sit
Well,
there.
in general, it's actually, I mean, like
It's
when
a
you had it
shading
on,
issue, right?
it's actually up above most people, right?
Okay.
So.
Well, me, because I'm short, but what about?
No, I mean in general, it's up above most people, and sometimes I mean you'll get transient noise, but that's I mean compared to the big giant static environment that's around,
Big
it's
picture.
it's
Just stitches,
Yeah.
stitches it together.
it's a little bit
Do
of
you
math.
have a flare on there, and you'll detect heat, and that's how you know it's a person there?
No, that's not how we do people detection. I mean, it's outlier, right? So you could see it's just an outlier, right? Like you can see if you're looking at data, you know, if all the data is moving this way and some data's and a tiny blob of data is moving this
It
way, it's
ignores it.
clearly not what you're looking
Right,
at, right?
you don't even see the data anymore. You're like blonde, brunette. right?
Exactly. Yeah. Yeah.
That's true.
Exactly. Something like that.
So what's the next step? What's not done with it, and maybe techniques or abilities for something like that that's you'd like to go to?
So I think the better, faster,
Cheaper.
cheaper. Yeah. So definitely trying to get more accuracy out of the sensors we do have, less hands-on time for the operator, either in the field or in a post-processing stage. So the less the data has to be touched later, the better. And then cheaper, as far as, like you said, there are cell phone quality sensors that are coming on the market that have some interesting properties, and they, if we can take our same set of algorithms and adapt them or fuse them with these new cheaper set of sensors, obviously that's a win. If you can make a backpack that costs $250 or $500, whatever a cell phone costs, and do the same thing, then yeah, obviously that's a win, because everybody can do it.
Do you think that you could have this thing streamlined to the point where you give them the final deliverable on site right there?
I don't know. I mean, I think it's largely going to depend on what people need and a deliverable, right? There's obviously there's always some level of insight that the system can't get, right? So like the system can't see into walls.
And can the system?
So it's a limitation of physics.
Can
really.
can the system detect that this is the bathroom versus the kitchen? I mean,
Yeah, we can
is that-
make determinations like that.
That's human.
Some of that's human, yeah. And I think obviously the more real world scenarios we get, we can ring out. That's the other kind of
Add to the
improvement,
database.
is you gotta just keep ringing out corner cases, right? It's kind of like the Google autonomous car. The more miles you put on it, the more things you see. You walk into, you get a call and they're like, well, we walked into a building and it's entirely, plastic sheeting or something, something just completely crazy, and you're like, well, I guess we can figure that out, right? Like so those type of situations come up, or can we do a fast food restaurant? Can we do whatever, right? And so
The answer is yes. We'll figure it out.
yeah, yes, we're smart.
is there a particular thing that really throws you off? Like, say you wanted to map something and there's a waterfall there. Would that really throw off the instrumentation?
I mean, I would say if you had a room that was filled with smoke and fog, that would probably be an issue. I don't know if anybody's
Yeah,
run
right.
into
But
that
well,
yet.
a nightclub, or a haunted house. I
A
want you to
nightclub or a haunted house.
map my
other
haunted
problems.
house.
Well,
I want you to map my haunted
hopefully
house.
somebody at Disney
I have,
will hear
I have,
this.
I have a rubber room. I have a fog room. I have a waterfall in there, and then I have a walk-in oven. I want you to map this for me. Can you do it?
So mirrors are interesting, yeah, because optically,
Mirror room, yeah, that.
mirrors. Frequently, you don't find a room entirely full of mirrors, though. So
I'm running a circus.
Sure. Yeah.
I mean,
Dan is finding the pathological
to the system when it looked like you're looking into a doorway.
Exactly. Yeah. I mean, that's exactly what it looks like, right? So you point a camera at a mirror, and it looks like you see the thing, Snell's law, or you see the reflection, and So fortunately, that's pretty easy to detect algorithmically, and if it wasn't easy to detect algorithmically, usually somebody can say, I don't think that looks right, clearly not. Not urinals on the other side of this wall in the men's bathroom because the urinals are back there, right? So,
or you see two dots.
Are you tagging all these statistics with an actual picture that you can look at, to help you out?
So the system collects video.
So if you see a statistical anomaly, you're like, what's that? You can reference a picture.
Yeah, you can always jump back and see, and a lot of times the operators are, they're talking too, so they can
have a narration.
They can add audio notes. They can add annotations and say, well, I'm about to go into this room and it's a fun house at a circus. Why did you guys send me here?
Yeah.
I'm terrified of clowns.
It's like, so I have no idea, but why? But Dan has a waterfall in his house and a walk-in oven.
I would imagine you see stuff, clutter or whatever, and you see shadowing. Type of stuff.
Always interesting things.
Yeah.
Does it map furniture too?
It can. Yeah. So the 3D system, definitely. Yeah.
If I didn't want that couch in my floor plan, would you have to edit it out manually? Because, does the thing know the difference between a table and a raised floor?
Yeah, that's a good question.
Yeah.
Because they walked in here and this guy just walked around this.
This is right.
Yeah, so that goes back to, you can have a person look at the video and say, well, that's clearly a table, right?
Okay.
And so a lot of that, a lot of kind of the academic literature, obviously machine learning and deep learning and all that stuff has become super, super popular lately. But it's one of those things that you could spend, hundreds or thousands of hours of engineering time coming up with the table detector that can detect a table 99.8% of the time. Well, that costs a lot of money, right? Like you could also just have somebody take 1 second every time that situation comes up. There are things that make sense to automate. There are things that don't make sense to automate, I guess, and at some point you gotta.
Well, it's typically high frequency, type things, right? That are.
We see a lot of walls.
Yeah. Right.
Right. We don't see a lot of waterfalls.
So no, this is free form, right?
Sure.
The table discussion. This industry, this type of stuff. What are some of the most challenging obstacles to overcome? Like what would be, ideal golden standard type thing to have happen?
So I guess, obviously I've only been with the company for a year, but kind of the sense that I've gotten is that there are a lot of people that think it's a really great idea, but they're also very reluctant to adopt new technology. Mm-hmm. So if you think about selling to construction, right, real estate, and we're also talking about, doing pre-fire, pre-incident safety plans. So like a building like this, they would have a plan that would be on file with the fire department or HEMSI or whatever, so that in the case of an incident, those first responders could come in and have prior knowledge of what they're getting into, right? And so those are kind of some of the big kind of verticals out there. And some of those people are reluctant to adopt new technology, right? And so I think on paper, obviously not being a sales guy, I think on paper it's kind of difficult to get that impact across, like, hey, this is really going to make your life a lot better, right? But then a lot of times when people see it, and definitely when people see it in action, it clicks, right? And so I think that's kind of a hurdle, like.
Yeah.
I think what you could do, which would sell them, is have their one guy doing it with the standard surveying, and then have you guys do it another time. Then let them compare the results and compare the costs and see who wins.
Yeah, and I think that's a big selling point as well, right?
Well, I was wondering, because I know probably weeks or months ago, mentioned from a mapping industry standpoint, the starting point being an interesting deal where, it's how do you auto-recognize where you are and all that type of jazz. I don't know what the term is, but it's initialization problems, right?
Yeah, that's also kind of an interesting.
That's just a field problem in general, right?
Yeah, and I think a lot of that. It doesn't necessarily have to be a technology problem either, right? So you can make that a process problem, which I think. But definitely after the merger, right, and being able to say, well, this is the process that you'll follow, and
yeah. But what is the initialization problem?
So a lot of the sensors have some startup, turn on variation and noise, and so some of them have biases and noise models that change from one run to another, and so characterizing all of those things and collecting enough data to characterize those things. The other thing is calibration, and so we spend a lot of time thinking about not only kind of calibrating the system when we give it to the operators initially, but there's also thought given to, like, obviously these systems are used in a whole bunch of environments and they're moved around a bunch, right. and things happen, right? They get banged into door frames, right. And they get, stuff happens, right? And it's just part of using it. And so there's some thought to how you detect, kind of built-in self-test, self-health, kind of, is the system still producing the type of data that it should be within the acceptable error limits? That sort of stuff is also, a challenge that we have to think about, right? So it's not just like, oh, I've got this sensor, I'm going to turn it on and everything's going to be okay. It's like, I've got this sensor and, the first time I turn it on, it may be perfect, and the next time I turn it on, it may not work at all. Well, that infrequently happens. But, I think anybody who's worked with, I know, like, the inertial units, there's a lot of really low-cost accelerometers and gyros out there. And anybody who's had some, like, hands-on time with one of those understands how crazy that data can be, especially compared to much, much higher-end IMUs, right?
Yeah.
So, inertial measurement units range on a spectrum from like $1 to, I don't know, very expensive, probably six figures.
Oh, wow.
Depending on what you're guiding, right? If you're guiding a submarine, you might want an expensive IMU.
Yeah.
Right? There's not a lot of GPS where submarines go. So,
What did you have a question?
Oh, what's like the radius, I guess, of sensitivity of that?
20 to 30 meters.
20, 30 meters. That's pretty big.
Yeah.
So like,
obviously, like if you're inside,
Yeah.
20 meters is usually outside of.
Yeah.
You've hit something before you get to 20 meters.
Yeah.
There's a wall or something.
So I was saying, if I was like some explorer, I was trying to map out a cave, go into a cave, and also how detailed. Like, caves are going to be a lot more rugged and stuff than a room would be. So
Yeah.
how detailed can that get?
So for caves, that would be particularly challenging, right? I don't think that what we have would lend itself very well to that sort of environment as it stands. It could be adapted to that. I think you'd want to switch to probably cameras that were much more sensitive in low light, or more active sensors, things that were actually broadcasting out their own power.
So are you biasing for flat surfaces? That's what's going on?
So it's not necessarily biasing for flat surfaces, but
Your equipment's tuned.
yeah, obviously, if
tuned bias.
The bigger thing is lighting, right? Like, so if you're just operating on like normal
But he
office
could bring in
lighting,
some spotlights to help.
yeah. That's always more complicated, right?
Yeah.
I mean, light does weird things, and it does weird things like reflections and stuff. It can play tricks on cameras, just like it plays tricks on
Us.
people, right? And so I wouldn't say, yeah, we could take this backpack into a cave and do it, right? So we could definitely the 3D system we could take in and capture some pretty cool stuff, and it's pretty portable. So if you needed to squeeze down, I mean, like the actual sensor component of that is pretty small, right? So you could hand carry that if you wanted to, rather than as a backpack. And I can show you some of the data. We collected data from in here. I did the grotto area at Big Spring Park. So it's important, so obviously we have an existing system that is fielded, and we're providing services around, but we also have prototype systems that we're kind of expanding in different directions with different types of data. So.
I was going to ask, like, how well does, because you said you did the grotto, I was going to ask you how well does it do outdoors?
Yeah, it works fairly well outdoors, yeah. So I guess I haven't tried it, in the middle of the desert in Arizona or whatever, but yeah, just out here in the grotto or out around outside of our building, I've had no problem. So, I mean, it's fundamentally pretty similar technology to what the Google car uses. So,
because I was wondering, like, that, because if I want to see the floor, like, how does it feel to the person wearing it? Like, how does that all work out?
For the 3D, it does field of view. Yeah, approximately where the operator is, and you can,
like an umbrella.
yeah.